Welcome to MATLAB Module 5, Symbolic Math Toolbox. In this module, we will learn how to perform symbolic computations using MATLAB.
After watching the module, you will be able to 1. Describe what a MATLAB toolbox is, and what they are used for. 2. Define the purposes of the symbolic math toolbox in MATLAB. 3. List the major mathematical tasks the symbolic math toolbox can perform. 4. Describe how to find specific functions contained in the symbolic math toolbox. 5. Differentiate between regular built-in MATLAB functions and a specific toolbox's functions. 6. Describe MATLAB's symbolic object data type. 7. Perform different mathematical symbolic operations using functions from the symbolic math toolbox.
What is a toolbox? In a very general sense, MATLAB is a collection of a graphical user interface in which we can perform specific numeric tasks by invoking certain built-in functions, commands or programming constructs. To do so, the user first specifies certain commands or instructions, then MATLAB performs the given task and later the results are outputted. In order to expand and improve MATLAB's functionality, several libraries of functions have been written to expand the base of built-in function available in MATLAB. In general, these libraries contain functions that are related by a specific field of study. These libraries are referred to as toolboxes. When a function contained in any of these toolboxes is invoked, MATLAB has to call said function from the toolbox and then outputs the result of the call.
The symbolic math toolbox in MATLAB is one of these special libraries that allow MATLAB users perform symbolic operations, as opposed to numeric operations. To find specific information regarding the toolboxes installed in your version of MATLAB, simply access the Product Help, select the Contents tab, and scroll down all the multiple toolboxes until you find the one you are looking.
According to MATLAB's description of the symbolic math toolbox, symbolic math provides tools for solving and manipulating mathematical expressions, and performs variable precision arithmetic. Symbolic math is particularly useful for differentiation, integration, linear algebra operations, simplification, transforms, variable precision arithmetic and equation solving.
To find specific functions contained within the symbolic math toolbox, simply go to the Product Help, select Contents tab, and scroll down to Symbolic Math Toolbox. Once you do this, you will see that all functions are arranged according to a specific task they perform. For example, if you wish to find which functions are available for calculus operations, you simply select Calculus. It is important to note that these functions are contained within the symbolic math toolbox, and therefore if this toolbox is not installed, MATLAB will not be able to reference the functions. Therefore they are different than regular built-in functions because different versions of MATLAB may not contain this toolbox. It is not expected of you to memorize all functions contained within the symbolic math toolbox, but it is recommended that you take the time to explore the different tasks these functions perform so that you are familiar with the contents of the toolbox.
Before we can start using any of the functions contained within the symbolic math toolbox, it is necessary to understand a new data type that the toolbox introduces: symbolic objects. Symbolic objects are a special data type that allows the user to perform mathematical operations analytically without calculating numeric values. Symbolic objects can represent symbolic variables, numbers, expressions and metrics.
Symbolic objects need to be declared before they can be used. To declare a symbolic object, we use the function sim, or the command sims. The syntax for sim is shown here. It requires quotation marks and the use parenthesis as shown. It is best for creating symbolic numbers, expressions or symbolic objects within function scripts. Sims on the other hand works like a command. It does not require parenthesis nor quotation marks and it serves better for creating multiple symbolic variables. Sims is a shortcut version of sim.
Symbolic variables can be created using sim or sims. To create two symbolic variables, A and B, the following two options can be written into a MATLAB script.
To create symbolic expressions, use sim. One simple example is presented here. Note how the expression contains only numbers. If we create a symbolic expression containing symbolic variables, we can do the following. However, if we wanted to perform an operation on f, all other variables must be declared as symbolic variables. A better alternative for the previous expression is to first create the symbolic variables, and then define the expression. Now we are ready to start using symbolic math functions. In this example, we will use a function to differentiate the expression given with respect to x. Since we are intending to differentiate, we will use the function from the calculus submenu. The function is called diff. You can access the product help for this function to know more about the syntax and use. First, declare the variable x. Then, simply call the function diff, which takes the expressions as its input and the variable. The result from this operation will be the derivative of sin of x squared.
Consider the following expression. Using a symbolic math function, simplify the expression. To do this, we will use a function called simplify. The function simplify simply takes the expression as an argument and returns the simplified expression. As probably noticed already, using functions from a toolbox is exactly the same as using a function previously discussed in class. The only difference here is that the symbolic objects need to be created in order to use the functions.
As a final note, in most problems, the function to be used will not be provided as part of the problem statement. To decide which function from the symbolic math toolbox is most appropriate, you will need to access the product help and search from the function in the toolbox. In this class, you will only need to be familiar with the following list of functions.
Use the symbolic math toolbox from MATLAB to obtain symbolic solutions to the quadratic equation. You will need to decide which function from the symbolic math toolbox is most appropriate for this. After searching the product help, we determine that the function solve will be used. The function simply takes the equation and the variable to solve as two arguments. Notice how if the equation is not set equal to anything, MATLAB will assume equal to 0.
Use the function EasyPlot to generate a figure with multiple graphs of the following symbolic expressions. The function EasyPlot simply takes the symbolic expressions as input as shown.
In this module it was described what a MATLAB toolbox is, and more specifically, what the symbolic math toolbox is. A new data type, the symbolic object, was introduced. Examples to define symbolic variables, expressions and metrics were given. Additionally, examples on how to use functions contained within a toolbox were given.